In the previous videos of this session, we have created a new thread by using the thread class. We have created a new thread by using runnable interface. But can we create more than one threads programmatically? Yes, we can do that. And one more thing, there can be different user-defined names for different threads. Namaste everyone, I am Gyan and you are watching the session 20 of Java and Web, Multithreading in Java. We already know that all the threads have names, but we can provide a name to a new thread programmatically. Or if we do not provide the name programmatically, then the compiler will provide a name to that, like thread 0, thread 1, thread 2, etc. Here in this case, we are going to create more than one threads. Here we have two Java files, mythread.java and createThread.java. In the createThread.java, we have a class createThread. In the class createThread, we have the method main. And in the method main, we are creating a new object of type myThread class. The class myThread implements the runnable interface. And it implements the method run of the runnable interface, which prints the result of 10 divided by 0. That will cause an arithmetic exception, division by 0. After creating a new object of type myThread and storing its reference to the reference variable empty, we are creating a new array of type thread. Hopefully, you have watched all the videos of session 13 of Java and Web and you know how to create an array of objects, or more precisely, an array of reference variables. So here we are going to create an array of reference variables of type thread. So we are creating an array of reference variables of type thread with 5 elements. And reference to that array will be stored into the reference variable t. We know that an array is an object. So reference to that array object of type thread will be stored into the reference variable t. And various elements of that array object of type thread will be reference variables of type thread. Hopefully you know these concepts. Now we are going through a for loop. And the loop is iterating from I is equal to 0 to I is equal to 4. And for each index I, we are assigning a new reference to the newly created object of type thread with empty as its argument. So unlike previous examples, at this time we are assigning new values to each element of the array t, and that value is a reference of type a new thread object, and we are creating this thread object by using empty as an argument to the parameterized constructor of the class thread. So now we have an array, and all the elements of the array contains a reference to a new thread object. So by now I have 5 different thread objects. Those can be start one after another, and that's what we are doing here. We are again iterating through a for loop from I is equal to 0 to 5, and then we are calling the start method on each reference variable in an array t. So what we are doing here, we are calling the start method on an object whose reference is stored into the reference variable t0, then we are doing the same on the reference variable t1, then we are doing the same on the reference variable t2, then t3, then t4. After completion of this for loop, all the 5 threads will be started. And of course the thread main is automatically executing. So we have 6 threads now available in the Java program. After starting all the threads, the thread main, means the method main, which is executing in the thread main, is printing the value of 10 divided by 0, which will cause arithmetic exception. For each newly created thread, the run method will execute in different threads. Means this run method will execute in 5 different threads simultaneously. For the thread 0, this run method will execute. For the thread 1, this run method will execute. For all our created 5 threads, this run method will execute simultaneously. And all the threads will cause arithmetic exception. That's why here in this case, all the 6 threads, the thread 0 to thread 4 and the thread main, all the 6 threads will cause arithmetic exception, division by 0. Let's check the output of this code practically. Open mythread.java, and this is the same code as we have seen. Open createThread.java, and again this is the same code as we have seen. When you call ti.start, it will start the run method in a new thread. So you are calling ti.start for 5 times, one for I is equal to 0 to I is equal to 4. So it will call the run method 5 times in different 5 threads. Now compile these two codes, Java C createThread.java and mythread.java. It compiles fine. Now run it. Java create thread. Press enter. All the threads are throwing exceptions in separate. Exception in thread 0. After that, it had to print something, but the thread 0 was preempted from the CPU and the thread scheduler gives a chance to the thread 1. Then after, the thread 1 prints exception in the thread 1 java.lang.arithmetic exception division by 0 in mythread.run. It prints complete. After preemption, the thread 0 did not get a chance on the CPU again. After the thread 1, who is getting a chance on the CPU is the thread 4 and it's printing exception in thread 4. Then after the thread 4 got preempted from the CPU. Then who got the chance? The thread main. After printing this thing, the thread main got preempted from the CPU. And then who got the chance? The thread 3. It's printing exception in the thread 3. After that, I do not know who is printing this statement. It's printed by thread 0 or it's printed by thread 4 or it's printed by thread 3. I don't know. Because only thread 1 is completed till now. These 3 threads and the thread 2 is still not completed. So I don't know who is printing this one, java.arithmetic exception. Okay, any one of these 3 got a chance on the CPU and printing it. After that, here you can see the thread 2 is getting a chance on the CPU. So actually we do not know which thread will get a chance on the CPU and when which thread will be preempted from the CPU. This is not in our control. If you execute this code once again, then it will print something different. You can check here. Now it's printing something different, very different than previous one. If you execute it, you will get some other result. You will execute it, you can get some other result. You don't know which thread will get a chance on the CPU and which thread will be preempted from the CPU. You don't know actually, and you do not have any control over it. So by now, we know that the default names of the threads are thread 0, thread 1, thread 2, etc. Can we give our own name, our user-defined name to a thread? Yes, we can do it. Programmatically, we can do it. Means what I'm asking here, is there a way to print name of the thread? Yes, of course, without raising the exception. Because when you raise the exception, then it will print exception in the thread name and then it prints rest of things. I do not want to raise an exception, but I want to print the name of the thread. Can I do it? Yes, we can do it. We will see how to do it. Can we create more than one threads? Yes, we can do. We already did it just now. Can we set new name to a thread? Instead of depending on the default names, can we set a user-defined name to a thread? Yes, we can do it. All these 3 things we can do. We already did this one. We have created more than one threads. Now we are all set to get name of a thread and we are all set to set name of a thread. Now how to get name of the threads? In the thread class, we have a static method called currentThread, which return reference to currentThread object. So this method return a reference of type thread. This is a native method and a static method. That means this method can be called just by using the class name thread. So when we call thread.currentThread, it will return the reference of the current thread. Then on a thread object, means the reference returned by this method. Then on a thread object, we can apply getName method of thread class to get name of the thread as a string. That means whatever the reference returned by the currentThread method, on that reference, when we call the method getName, we will get name of the currently running thread. Let's use these 2 methods to get name of the thread. So this is the simple program. The program name is createThread.java, which has a class createThread. In the class createThread, we have the method main, and in the method main, we are calling the currentThread method of the class thread, which returns the reference of an object of type thread corresponding to the thread main, and that reference will be stored into the reference variable t of type thread. Then after, on the reference variable t of type thread, which stores the reference of the current thread object corresponding to the thread main, we are calling the method getName on that thread object, t.getName. By using the reference variable t, we are calling that getName method, t.getName. That will return the name of the thread corresponding to that thread object whose reference is stored into the reference variable t. It returns the name of the thread as a string, whose reference will be stored into the reference variable name of type string. When we print the reference variable name, it will print the name of the thread, that is main. This is the somewhat bigger code. Here we have two Java files, createThread.java and mythread.java. In the createThread.java, we have the class createThread. In the class createThread, we have the method main. In the method main, we are creating a new array object of type myThread, whose reference will be stored into the reference variable empty, and size of the array is 5. Look at the class myThread here. Here we are not implementing the interface runnable, but we are extending the class thread. That's why here in this case, we are implementing the multithreading in Java by using the class thread. Inside the class myThread, we are overriding the run method. And in the run method, we are calling the currentThread method of the class thread, and that will return a reference to that object corresponding to the currently running thread, and that will be stored into the reference variable t of type thread. When we call the method getName by using the reference variable t, we will get the name of the currently executing thread. So this will be happen when it will execute the run method. Now let's come to the main method. Here we are creating a new object of type myThread and assigning it to a reference variable of type myThread, which is an element of the array referenced by the reference variable empty. So in each element of the array which is referenced by the reference variable empty, we are assigning a reference to the new object of type myThread. And here myThread extends thread. That's why in this case we are not creating an object of type thread. We are creating an object of type myThread and assigning it to empty. So this is how it is slightly different from the earlier code. After that, again we are iterating through the 5 values of I, from I is equal to 0 to I is equal to 4, and for each case we are calling the start method on an element of the array referenced by the reference variable empty. That's why one by one here we are starting all the threads whose references are stored as various elements of the array. After that, we are calling the currentThread method by using the class name thread, and that will return the reference of a thread object corresponding to the current thread, means corresponding to the thread main, and that will be stored into the reference variable t. And when we call the method getName by using the reference variable t, it will return the name of the current thread, that is the name of the thread main. So the string main will be returned by this method that will be stored into the reference variable name, and when we print name, it will print the name of the current thread, that is main. So ultimately what we are doing here, we are printing the names of all the threads. The name of the thread main, the name of the thread 0, the name of the thread 1, the name of the thread 2, the name of the thread 3, and the name of the thread 4. Let's try this code practically. Open mythread.java, and this is the same code as we have seen. Open createThread.java, and this is the same code as we have seen. Try to compile these two codes, Java C, createThread.java, mythread.java, it compiles fine. Now run it, Java createThread. It executes fine, but you cannot predict the order of execution. If you execute it once again, the output may be different. And you can check here the output is different. You do not have any control over it. Which thread will be picked to execute on the CPU, which thread will be pre-empted before its execution from the CPU, you do not know, and you do not have any guess about it. So actually you do not know which thread is going to execute when. You do not know. The code is similar to previous one, with only difference is that instead of using here t.getName, we are directly calling here getName, because notice here the method myThread extends the thread, and the method getName is a part of the class thread. That's why the method getName is inherited to the class myThread also. That's why the method getName is a part of the class myThread also. That's why we can use the method getName without using any reference. Now look at this code. What we are doing here, before starting a new thread, we are printing the name of the thread is getting started. Means here we are using a reference variable of type myThread. Of course, the myThread contains the method getName because it got inherited from the class thread to the class myThread. That's why by using the reference variable of type myThread, we can call the method getName. So here we are calling mi.getName. That will print the thread name which we are going to start, and then we are printing starting. After that, it got started. After starting it, in the method run, we are printing the name of the thread plus executing. Means in the method run, that thread is executing. Then in the method main, we are getting the name of the thread main, and then after we are printing main executing, because name of the current thread here is main. So we are printing main executing. When you execute this code, then you can see here thread 0 is starting, thread 1 is starting, thread 2 is starting. We have to start from the thread 0 to the thread 4. Now the question is when these three threads will start. These three threads will start when the method main is executing. Means when the method main is in execution state, then only these three threads can start. So here for these three statements, the method main, that means the thread main, is executing. After that, the thread main got preempted from the CPU, and the thread 0 got the chance for the execution. That's why it's printing thread 0 executing. After that, again it's printing thread 3 starting. That means again the thread main got the chance on the CPU. Thread 0 got preempted or finished its execution, and then after the thread main got a chance on the CPU, which has started the new thread called the thread 3. Then after the thread main preempted from the CPU, and the thread 1 got the chance for execution. After that, the thread main again got a chance on the CPU. When the thread main got a chance on the CPU, it started the thread 4. Then after, the thread main got preempted from the CPU once again. After that, thread 3 got a chance on the CPU to execute, thread 2 got a chance on the CPU to execute, thread main again got a chance on the CPU to execute. The thread main here got preempted once again, and thread 4 got a chance on the CPU for execution. And this is the one case. Actually, we do not have any idea which thread will get a chance on the CPU and which thread will be preempted. We do not know. Output varies for different runs. We talked a lot about creating multiple threads in a Java program. But can we give a user-defined name to all those multiple executing threads? Yes, we can do that. We can set name of the thread at the time of thread creation using thread class constructors. These are the four constructors using which we can set the name of the thread. We will use all these constructors in various other videos of this session. Even after thread creation, we can change its name by using the method setName. Here we have two Java files, createThread.java and mythread.java. In the createThread.java, we have the class createThread, which contains the method main. In the method main, we are creating a new array object of type mythread. There are total 5 elements in the array object of type mythreads. Reference to that array object will be stored into the reference variable empty. Let's go to the mythread class and check what is there. The class mythread extends the class thread. In the class mythread, we are defining a parameterized constructor with string reference as its argument. That parameterized constructor calls the constructor of its superclass with the same parameter s. The superclass of the class mythread is the class thread. That means the parameterized constructor of the class mythread is calling the parameterized constructor of the class thread with same string reference as its argument. Then after we have the method run in the mythread class. In the method run of the class mythread, we are printing the name of the current thread, and then we are printing the string executing. So the thread because of which the method run is executing, here we will print name of that thread plus executing. Let's come to the method main of the class createThread. After creating that array, we are executing through a for loop from the value of I is equal to 0 to the value of I is equal to 4. In that for loop, we are creating a new object of type mythread with gyan dash as a string, and we are concatenating an integer to that string. That means for I is equal to 0, the string will be like gyan 0. For I is equal to 1, the string will be like gyan 1. So it is like gyan 0, gyan 1, gyan 2, gyan 3, gyan 4. That's how here we are calling the parameterized constructor of the class mythread. And the same string got passed to the parameterized constructor of the class thread. So here we have created 5 different objects of type mythread with 5 different parameters whose references are stored into the 5 different elements of the array. Then after, we are printing the name of the thread, and now the name will be this one, gyan0, gyan1, like that. The name of the thread plus starting, and then we are starting that thread. After that, the new threads which got created have the name gyan0, gyan1, gyan2, gyan3, and gyan4. So here it will print gyan0 starting, gyan1 starting, like that, and here it will print gyan0 executing, gyan1 executing, like that. After starting all these 5 threads, here we are getting the name of the thread corresponding to the method main, that is the thread main, and then we are printing the string main executing. So this program is similar to previous one, only difference is that we have assigned here a user defined name instead of using thread0 thread1. Here we are using gyan0 gyan1. So the names of threads can be whatever you wish. Therefore this program is similar to previous one, just we are assigning different names to different threads. This program again similar to previous one, but here we are giving the same name to all the threads. All the 5 threads have same names. They have the name Gyan. They are not like Gyan0, Gyan1. Because you can see here, the string passed to the parameterized constructor of the class myThread is Gyan, and that got passed, means the reference to the string Gyan got passed to the parameterized constructor of the class thread. That's why all the 5 threads created have the name Gyan. This code is again similar to previous one, only difference is that here the class myThread implements the interface runnable. In the previous code, the class myThread has extended the class thread. But here the class myThread implements the interface runnable. That's why here in this case, we cannot use the method getName directly. We need to call the currentThread method of the class thread. Then we need to call the method getName by using the reference variable t of the class thread. And other difference is that here we need to create a new object of type thread, not of type myThread. And here we need to pass 2 arguments to the constructor of the class thread. One is the reference variable empty, which is a reference variable of type myThread, and other one is a string like gyan0, gyan1, gyan2. So here we need to pass 2 arguments to the parameterized constructor of the class thread. And rest of the codes are same. We can change the name of a thread while executing it. Let's see an example. Here we have set name of the thread as gyan, where G is capital and rest of the alphabets are small. But while running a thread, first we are getting the reference of an object of currently running thread. That reference will be stored into the reference variable t of type thread. When we call the method getName by using the reference variable t, we will get name of the current thread, and that will be stored into the reference variable s of type string. When we call the method toUpperCase by using the reference variable s, then all the elements in the string refreshed by s will be changed to uppercase. And look what we are doing here with this toUpperCase method. We are passing it as an argument to the setName method of the thread class. By using t.setName, we are setting the name of the thread at the execution time. Before execution, the name of the thread was different, and during execution, the name of the thread got set to something different. That's why while starting, the name of the thread was gyan0, gyan1, gyan2, but while executing, the name of the thread got changed to gyan1, where all the alphabets are capital. I will suggest you to go through all these codes, or you should watch this video 2 or 3 more times to understand the concept clearly. So I hope you got my all points. That's all for this video, guys. Don't forget to like and share this video, subscribe my channel on YouTube, like my page on Facebook, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.